Please write this problem. Next problem. Just go through the problem. A pre-stressed concrete beam of span 10 meter has a rectangular section of 120 mm wide and 300 mm deep. Is pre-stressed by a curved cable carrying an effective force of 180 kN. It's a rectangular PSC beam. Write the diagram. Write the cross section of the PSC beam. What is the dimensions? 120 mm wide and 300 mm deep. 120 by 300 mm. Pre-stressed by a curved cable carrying an effective force of 180 kN. The pre-stressing force P is equal to 180 kilonewton. In terms of Newton, it is 180 into 10 power 3 Newton. Okay. 180 into 10 power 3 Newton. The beam supports a total uniform distributed load of 5 kilonewton per meter, which includes the self-weight of the member. Including the self-weight, the load is given 5 kilonewton per meter. The beam is additionally pre-stressed by vertical cables imparting a stress of 2.5 Newton per mm square. This is important. Okay, this is the special case we are getting in this particular problem. Vertical pre-stress is also given. Okay, so write the longitudinal section of the beam. Longitudinal section of the beam. Okay. Write the neutral axis as well. Neutral axis. Then what it says is the beam is additionally pre-stressed by vertical cables imparting stress of 2.5 Newton per mm square. There is vertical pre-stress induced in the beam. Let me show that here in the longitudinal section. Okay, vertical pre-stress is equal to how much it is? 2.5 Newton per mm square. 2.5 Newton per mm square. Okay, in the direction of depth of the beam. The direction of depth of the beam means reinforcement or the tendons are provided in the vertical direction and pre-stress is induced to the beam in the vertical direction. Okay. Estimate the nature of principal stresses developed at the support section. We have to find the principal stresses, sigma max and sigma minimum. The cable has zero eccentricity at the supports and an eccentricity of 100 mm below the centroid at the midspan. It's a parabolic cable having zero eccentricity at the supports and eccentricity of 100 mm below the CGC at the midspan. Okay. Let me write the diagram of the cable. So at the center of the span, the eccentricity is 100 mm. Okay. So here it is not particularly mentioned as parabolic cable. The cable has a zero eccentricity at supports and an eccentricity of 100 mm below the CGC at the midspan. Okay, not particularly mentioned whether it is parabolic or triangular. In the absence of the data, okay, you assume it as parabolic only, 100 mm. Okay, parabolic cable only. So let me write the given data once again. B is equal to 120 mm width of the beam. Depth of the beam D is equal to 300 mm. Then length of the beam is given as how much? Just see, 10 meter it is. Length of the beam is given as 10 meter. So length of the beam L is equal to 10 meter or 10,000 millimeter. Okay. Then the uniform distributed load, all inclusive of load that is 5 kilonewton per meter. Just mention that load also on the beam. How much it is? 5 kilonewton per meter. 5 kilonewton per meter. Okay. So factor load will be how much? UDL is given as 5 kilonewton per meter. So factor load will be factored load will be 5 into 1.5, which is equal to 7.5 kilonewton per meter. 7.5 kilonewton per meter. Okay. And vertical pre-stress, it is given 2.5 Newton per mm square. Nothing but Fy it is. Vertical pre-stress. Vertical pre-stress is given as 2.5 Newton per mm square. 2.5 Newton per mm square. Okay. And eccentricity E is given as 100 mm. E is given as 100 mm. Okay. What is the question? To find the nature of principal stresses developed at the support section. So we know the formula. Just write the formula. Sigma max or sigma minimum is equal to Fx plus Fy whole divided by 2 plus or minus half of root of Fx minus Fy whole square plus 4 into 2 square. Okay, where Fx is equal to horizontal pre-stress, which is calculated as pre-stressing force divided by area of cross section, P by A. Pre-stressing force is given in the problem. It is 180 kilonewton or 180 into 10 power 3 Newton. Area of cross section is 120 by 300. 120 by 300. So which gives 5 Newton per mm square. Please cross check the answer. Then Fy is vertical pre-stress. Vertical pre-stress. It is directly given in the problem. Okay, in the previous problems it was 0. Vertical pre-stress was not there. But in this problem, it is given as how much it is? 2.5. 2.5 Newton per mm square. Okay. Then what else is required? Fx we got, Fy we got, tau v is required. Shear stress. Okay. For tau v, we have the formula. What is the formula? Vu into Ay by divided by Ib is the formula. Okay. The procedure of finding the shear stress is similar to that of previous problems. Okay. Total load acting on the beam, factor load is how much? 7.5 kilonewton per meter. First we will find this Pu. Okay, shear force. For that, you find shear force due to the load. Factor load is how much? it is 7.5 kilonewton per meter. Total length of the beam is 10 meter. 10 meter. Therefore, reaction at the supports. Reaction at the support will be WL by 2, which is equal to 7.5 into 10 divided by 2. What is the answer? It is 37.5 kilonewton. That too in upward direction, or 37.5 into 10 power 3 Newton. Okay. Now, along with that, along with this shear force due to the load, okay, there will be shear force due to the pre-stressing force as well at the support. Okay, that also we need to add with this value to get the net shear force. Okay, it's a parabolic cable. Correct. It's a parabolic cable. So we need to add vertical component of this pre-stressing force, means P sin theta value. P sin theta value. Okay. So we know the formula for finding the sin theta of a parabolic cable at the support. Okay. We know that. Sin theta is equal to, what is the formula for parabolic cable? It is 4E by L. 4E by L. So 4 into eccentricity at this midspan is how much? 100 mm. 100 mm divided by total length of the beam is 10,000 mm. 10 meter means 10,000 millimeter. So by this you will get sin theta as 0.04. 0.04. Then you can find vertical component. Therefore, vertical component or shear force due to the pre-stressing force P sin theta is equal to the pre-stressing force is given. It is how much? 180 kilonewton. So 180 into 10 power 3. 180 into 10 power 3 into 0.04. So the answer will be 7,200 Newton, and that will be in downward direction. Okay, from this diagram you can see the direction is downward. These directions are required for adopting suitable sign. Okay, therefore that net shear force will be equal to how much? The shear force due to the load plus 37.5 kilonewton. Okay, or 37.5 into 10 power 3 Newton plus 37.5 into 10 power 3 Newton minus downward direction minus 7,200 Newton. So the net shear force VU will be equal to, if you calculate, you will get the answer as 30,300 Newton. Please check the answer. 30,300 Newton. So this we got the value of VU. Now we'll calculate the static moment of area, AY bar value. Okay, we'll calculate AY bar value. So here I'll just extend the neutral axis here. I'll shade the area above the neutral axis. Okay, so total depth is 300. Half of the depth means how much you'll get? 150 mm. 150 mm. And distance of centroid of the shaded portion from the neutral axis will be how much? 150 divided by 2 again. It is 75 mm. This is the value of Y bar. Okay. Okay. A means area of the shaded portion and y bar is 75 mm. Distance of center of shaded portion from the neutral axis. Okay. Therefore, AY bar is equal to area of shaded portion is how much it is? 120 by 150. 120 by 150 into y bar is 150 divided by 2. Nothing but 75 mm. 75 mm. Okay. What is the answer that you get? It is 1.35 into 10 power 6 mm cube. Okay, to this we got the value of y bar, ay bar. Anything is needed, we need the value of moment of inertia I, correct? So I is equal to, we know the formula I is equal to BD cube by 12. So B, width of the beam is 120, depth of the beam is given as 300 cube divided by 12. Okay, it is 270 into 10 power 6 mm to the power of 4. 270 to 10 power 6 mm to the power of 4. Okay. Now width of the beam is given as 120 mm. That is also required. Okay. Next, you can substitute. Now we got all the parameters required to find the shear force. Okay. Now you can substitute all the values to get the shear force. Therefore, you can call this as equation number 1. Therefore, equation 1 becomes tau V is equal to VU into AY bar. VU is 30,300 Newton. 300 Newton. AY bar value is 1.35 into 10 power 6. 35 into 10 power 6 divided by IB 270 into 10 power 6 into 120 mm. The shear force, shear stress value after substituting all the values is 1.2625. 1.2625 Newton per mm square. 1.2625 Newton per mm square. Okay. Now we got all the required parameters to find this principal stresses. Okay, fx we got Fi, we got tau v also, just substitute. Okay. Therefore, sigma max is equal to what is the formula? Fx plus Fy by 2. 5 plus 2.5 divided by 2. 5 plus 2.5 whole divided by 2 plus half into root of Fx minus Fy whole square, half into root of y minus 2.5 whole square plus 4 tau v square plus 4 tau v square, 4 into 1.2625 square. Okay, answer is 5.52 Newton per mm square. 5.52 Newton per mm square. Similarly, sigma minimum is equal to 5 plus 2.5 whole divided by 2. This sign will change here, minus of half of root of y minus 2.5 whole square plus 4 into 1.2625 whole square. The answer is 1.97 Newton per mm square. Okay. So this we have calculated the principal stresses which is required for this problem. Okay. So this the solution of this particular problem is over. If there is any doubts, you can ask. Any doubts here? Thank you.